Okay. So this one I use, for this one I use a bunch of colors. Okay. And what we're doing is we are looking, we're looking at how the neurotransmitters communicate. Okay, so we're going to be, first start out. With neurotransmitters. And again, I will usually say NTs just because it's a lot to spell. Okay, so what are neurotransmitters? They are the chemical messengers of the nervous system. So we're looking at, we had talked about when we were looking at the structures and functions of the neuron, we were looking at how the neurotransmitters are stored in the end bulb. Now remember that end bulb can be called axon buttons, terminal buttons, something to do with the end, okay? So what we're going to look at here is we're going to draw our end bulb. Okay. And within the end bulb, okay, we have the neurotransmitters are stored in these tiny like circles. Okay, so I'm going to draw circles. And then inside the circle, I'm going to draw tiny triangles. Those tiny triangles are the neurotransmitters. So these circles, okay, these circles are called vesicles. Okay, and if you can picture these like tiny balloons filled with confetti. Okay, so these vesicles are going to package the neurotransmitters, and we saw that in that previous animation, how those vesicles go to the end bulb, and then it's almost like they pop, and the neurotransmitters are released into the synapse, which we'll look at in just a second. Okay, so here we have our end bulb, okay, and this is going to be called the presynaptic neuron. So now what we're going to do, okay, is we're going to go to the other side. And I'm kind of trying to draw little triangles here. So this part here is meant to look like little triangles. Okay, and those each are called the receptor sites. And this structure is the dendrite of another neuron. Because remember, we had talked about with our structures and functions that dendrites are going to receive messages. Okay, so they receive messages from another neuron, okay, in these receptor sites. So the space in the middle here is called the synapse. So the space in the middle is synapse. You can see it as synaptic gap, synaptic cleft, okay, something that'll have synapse. So what this is, okay, so we have our end bulb, okay, which is the presynaptic neuron, okay, because it comes before the synapse. Okay, so what would you guess this neuron's called? Yeah, postsynaptic. Okay. Okay. So now, what we're going to get into, okay, so again, I'm just going to review this since we're done drawing. Okay, the neural message is going to go from the axon to the end bulb. The end bulb, okay, is going to then release these neurotransmitters into the synapse. Okay, so what that looks like, I'm going to draw tiny triangles in the middle. Okay, and those neurotransmitters are going to hang out in the synapse. Okay, and there's a few things that can happen. Okay, first, what we want to happen, okay, is that the neurotransmitters are going to bind to these receptor sites. Okay, so they're going to bind to those receptor sites. And what I want you to notice, okay, is that these are triangles and these are triangles. Okay, so specific neurons are going to respond to neurotransmitters. If this is similar enough, okay, it fits like a lock and a key. Okay, so the neurotransmitter acts as a key and opens up the lock to the receptor site to tell it to do what it needs to do, okay, whether it's to fire or to stop firing. Okay, so that's what is going to happen. Now, okay, they bind and then they come back to the synapse. So there is something called, okay, they do something else, okay, which is something called reuptake. Okay, so on the presynaptic neuron, I'm going to draw these little red transporters. Okay. And what's going to happen here, okay, these transporters, okay, are going to take the neurons back in. Okay, so they're going to go back through, okay, and this process is called reuptake. So what happens is with the process of reuptake, so some of the neurotransmitters are going to be absorbed by the body, like they're going to be broken down. Okay, but the neurotransmitters are going to go through the process of reuptake. They go back through the transporter on the presynaptic neuron, and they're going to be repackaged back into the vesicles so that they can be released again. Okay, have any of you ever heard of like Prozac, Zoloft, they're antidepressants? Okay, and we'll look at this more on Wednesday, but this is how antidepressants work. Antidepressants, they're called selective serotonin reuptake inhibitors. That means they stop reuptake. Okay, so by stopping reuptake, the serotonin stays in the synapse longer so that it can bind to the receptor sites. Because the theory is that people with depression have low levels of serotonin. So we need to do something to make them hang out in the synapse longer so that they can bind to the receptor sites. Okay, and that's how other drugs work, and we'll be getting into that. Okay, so that is going to be or how it works. Okay, so now that we have it all drawn, I want everyone to look at the screen. Okay, so I can just go through the process one more time. Okay, so the process is, okay, you have your presynaptic neuron. So the axon is going to send the message to the end bulb, okay, which is going to release the vesicles into the synapse where it releases the neurotransmitters. Those neurotransmitters are then going to bind to the receptor sites of the postsynaptic neuron, which is the dendrite. We had talked about how dendrites receive messages. What happens then is after they've gone through this process of binding to the receptor site, okay, they're going to go through the transporters through the process of reuptake, okay, and then they're going to be repackaged into the vesicles so that they can go back into the synapse again. Okay, and that is how this works. Now, we have two things. Okay, we have two different types of neurotransmitters. Okay, so when we look at types of neurotransmitters, okay, we have two types that we're going to look at. The first, excitatory. Okay, excitatory neurotransmitters are going to say go. Okay, I need you to think of this like the accelerator of a car. Okay, so when we're looking at what I just showed you here, okay, this diagram, okay, let's say this neurotransmitter goes to the receptor site, it's going to tell the neuron to keep firing and sending the message. Okay, so one of our main excitatory neurotransmitters is glutamate. Okay, and that's going to tell it to keep firing, keep firing. Okay, our other one then that we have are inhibitory okay? And they're going to say stop. It's much more like the brakes of a car. So we have some neurotransmitters that are inhibitory. Our main one is GABA, okay? And it's that's short for something. It's an acronym, okay? But GABA, when it binds to the receptor site, is actually going to tell the neuron to stop sending messages, okay? So GABA is going to be an important part of sleep, okay, for relaxing us. We'll talk more about that with the neurotransmitters on Wednesday, okay? So are there any questions on this?